Hi dear students, am I audible? Am I audible? Hi dear students, this is Nandini Miss from Goscore Learning Center. We are the fastest growing education company in GCC. So our aim is to provide education to all. So today we will discuss alternating current part 3. So already we discussed part 1 and part 2. Today we will discuss part 3 topics. What are the part 3 topics regarding alternating current? LCR series circuit, we call it is a RLC circuit also. Resonance, power in AC circuit and power factor of the circuit. What is wattless current? Transformer, AC, generator. These topics today we will discuss regarding alternating current chapter. First of all, AC applied to a series LCR circuit. Already we discussed AC supply is connected to the resistor, inductor and capacitor. Today we will discuss AC is applied to a series LCR circuit. So here both three components, resistor, inductor and capacitor. These three elements are connected in series across a AC supply. Across a AC supply. Resistor or inductor, capacitor. This LCR circuit we called as a RLC circuit also. So when we are giving the AC, then current also passing through the LCR circuit. So since the circuit elements are connected in series, AC current in each element is same. It is in series connection, that's why current is same in each element. In resistor, in inductor, in capacitor, the current is same because of RLC are connected in series. That's why current is same in each element at any instant having same amplitude and phase. So for this circuit, what is the voltage equation and current equation? V is equal to, we know that it is a AC supply. V is equal to V naught sine omega t. I is equal to I naught sine. Here we are connecting series RLC. That's why in between the phase angle it is there. Voltage and current. That's why it is a omega t plus phi. For this circuit, V is equal to V naught sine omega t. I is equal to I naught sine omega t plus phi. Why? Because here we are considering phi phase. In between voltage and current, angle phi is there. Phase angle phi. When the AC supply is connected to the RLC circuit, the voltage across the resistor is in phase. Is in phase. We know that across a resistor, voltage and current are in phase with current. The peak value of voltage across a resistor is given by, already we discussed across the resistor, across the inductor, across the capacitor. What is the voltage across a resistor? V naught is equal to I naught into R. V naught, we will consider it is a R naught. Across a resistor, current into resistance. Across a inductor, the voltage across the inductor leads the current by pi by 2. Here what is happening in an inductor? Voltage is leading by the current with the angle of pi by 2. Then the peak value of voltage across the inductor is I naught into inductive reactance. I naught into inductive reactance. The voltage across the capacitor lags the current. Here voltage is lagging by the current with the angle of pi by 2. Then what is the voltage across the capacitor? VC naught is equal to I naught into XC. I naught into XC. So across the resistor, voltage is I naught into R. Across the inductor, I naught into XL. Across the capacitor, it is equal to I naught into XC. Then what is the phasor diagram for the RLC circuit or LCR circuit? Already we know that across a resistor, both voltage and current are in phase. Both voltage and current are in phase. But here, capacitor and voltage, across a capacitor, across a inductor, voltage is in same line but both are in opposite direction. Why? Inductor is in a inductor, voltage is leading. In a capacitor, current is leading. That's why here both are in same line but both are passing through a opposite direction. How we draw the phasor diagram for capacitor and inductor? Here I am considering capacitor voltage is greater than the inductor voltage. I am considering here capacitor voltage is greater than the inductor voltage. Then here it is VC, it is VL. The angle between the resistor voltage and inductor is 90 degrees, pi by 2. For capacitor to resistor voltage it is 90 degrees. It is VR. This is the phasor diagram for the LCR circuit. For a resistor, voltage and current both are in phase. For a capacitor, voltage in a capacitor, what is happening? Current is leading, capacitor voltage is lagging. In a inductor, inductor voltage is leading, current is lagging by the pi by 2 angle. By the pi by 2 angle. I am considering this, it is like a phasor diagram for the LCR circuit. For this phasor diagram, I am taking extension part, that is we called as a advanced phasor diagram. Here I am taking, here in this diagram, VC and VL are in, both are in opposite direction. Then I am considering both are in the same phase. What will happen here? I am adding both capacitor voltage and inductor voltage. I am adding both capacitor voltage and inductor voltage. Then we will consider the magnitude. How we draw the phasor diagram? Let's see. This is the resistor voltage. I am considering both are in same direction. Then this both are will be adding VC plus VL. VC plus VL. Then what is the resultant frequency? Sorry, what is the resultant voltage? What is the resultant voltage? What is the resultant voltage? I am considering this is the resultant voltage V. I am considering this is the resultant voltage V. So here we are considering only magnitudes. That's why I am considering here magnitude V or not. So this is V or not. Here also we will consider only, here also we will consider only magnitude. Then it will be V naught. It will be V naught. Then what is this one resultant here? What will happen for this? This will be VC naught minus VL naught. VC naught minus VL naught. Here we are applying the angle phi. This is the angle phi. This is the angle phi. This is the omega. This in between resistor voltage and capacitor and inductor voltage, how much angle it is? It is 90 degrees. This is the advanced phasor diagram. This is the advanced phasor diagram for a LCR circuit. First, I am taking resistor voltage, then inductor voltage and capacitor voltage comes same side. It will be added VC plus VL. Then here resultant voltage I am considering magnitude is V naught. Resistor magnitude is VR naught. It is a VC naught minus VL naught. This value will be VC naught minus VL naught. It means it is a magnitude of capacitor voltage and inductor voltage. Here we are considering only magnitudes. Here we are considering only magnitude. And the angle between the resultant phasor resistant voltage is phi. And the angle between here to here it is a omega t. Total is omega t plus phi. We know that I is equal to I naught sine omega t plus phi. Omega t plus phi is the omega t plus phi. The angle between the resistor voltage and VC plus VL is 90 degrees. We know that pi by 2 angle. So this is the advanced phasor diagram for a LCR circuit. See, this is the diagrams. By using this diagram, we will find out the impedance value. By using this diagram, we will find out the impedance value. I am considering here it is O. It is A. It is B. So, according to the triangle OAB, triangle OAB, here it is 90 degrees. Here it is 90 degrees. Apply Pythagoras theorem. Apply Pythagoras theorem. What is the Pythagoras theorem? Hypotenuse square is equal to adjacent square plus opposite square. So, here it is angle phi. Here it is angle phi. Here it is angle phi. Then apply Pythagoras theorem for triangle OAB. What is the Pythagoras theorem? OA square. It means hypotenuse square is equal to this angle. What is the opposite? For this angle, what is the opposite? VC naught minus VL naught. Okay, we will write AB square plus OB square. OA square is equal to AB square plus OB square. Then OA is here. Here OA is V naught. Here OA is V naught. OA is V naught. V naught square is equal to what is AB? VC naught minus VL naught whole square plus what is OB? VR naught whole square. VR naught whole square. We know that VR naught is equal to I naught or VC naught is equal to I naught into HC. VL naught is equal to I naught into X. We know that across a resistor voltage, across a capacitor voltage, across a inductor voltage. Substitute these values in this equation. What is the equation? V naught square is equal to BC naught minus BL naught whole square plus VR naught whole square. We will write it is a V naught square is equal to VR naught square plus VC naught minus VL naught whole square. We will write like this. Substitute that values here. V naught square is equal to I naught or whole square plus I naught XC minus I naught XL whole square. I naught XL whole square. V naught square is equal to, in these two terms, I naught is common. Take a common term, I naught square, R square plus XC minus XL whole square. Here it is a square term. That's why I am considering V naught is equal to root of I naught square R square plus XC minus XL whole square. Then V naught is equal to final equation I naught into root of R square plus XC minus XL whole square. V naught is equal to I naught root of R square plus XC minus XL whole square. Therefore, V naught, what is the equation? V naught is equal to I naught into root of R square plus XC minus XL whole square. XC minus XL whole square. When considering this I naught comes this side, it will be divided. V naught by I naught is equal to root of R square plus XC minus XL whole square. We know that generally according to the Ohm's law, V is equal to I or R is equal to V by I. Here it is not a resistor. It is a combination of resistor, inductor, capacitor. Another name it is a impedance Z. Impedance Z. Z is equal to V by I also. Here impedance also it opposes the current. It opposes the flow of current. What is doing the resistor in the circuit? It opposes the flow of current. Impedance also doing here opposes the flow of current. Here V naught by I naught is equal to what? Z naught or Z. Z naught or Z. I am considering it is a Z impedance. Z is equal to root of R square plus XC minus XL whole square. This is the formula for impedance. Here Z is equal to what? Z is equal to V naught by I naught. What is the units of impedance? It is similar to the resistance. That's why what is the units for resistor? Ohms. For the impedance also units is ohms. Then next one, impedance triangle and phase angle. So it is an impedance triangle. What is the equation for impedance? What is the equation for impedance? Z is equal to root of R square plus XC minus XL whole square. See guys, it is similar to the hypotenuse triangle. So we will write it is a Z square is equal to R square plus XC minus XL whole square. Compare with hypotenuse triangle. Apply Pythagoras theorem. So here it is a 90 degrees. Here it is a 90 degrees. Then what is the hypotenuse here? Impedance Z. Impedance Z. What is adjacent side? Or. What is opposite side? XC minus XL. XC minus XL. Here we are applying Pythagoras theorem. Hypotenuse is impedance, adjacent side is resistance, opposite side is XC minus XL. Then by using this, what is the phase angle here we are considering? Phi. Phase angle is phi. Phase angle phi. Then what is the power factor here? I am considering angle is the phi. Then what is the phase angle or power factor here? Tan phi. Tan phi. What is the formula for tan phi? What is the formula? Opposite side by adjacent side. Here what is the opposite side for this angle phi? XC minus XL is the opposite side. What is the adjacent side? Resistor. So this is the power factor equation for the impedance. Tan phi is equal to opposite side by adjacent side. Opposite side is XC minus XL. What is the adjacent side? Resistor. Then phi is equal to, angle phi is equal to tan inverse of XC minus XL by 4. This is the power factor. This is the phase angle equation. So what is the impedance equation? Root of R square plus XC minus XL whole square. Then what is the power factor, guys? Tan phi is equal to XC minus XL by R. It is the opposite side by adjacent side. What is the phase angle? Tan inverse of XC minus XL by resistance. This is the diagram. Impedance triangle. Here we are using Pythagoras theorem. It is a hypotenuse, it is a opposite side, it is a adjacent side. What is the phase angle? Phi. Power factor is tan phi. Next one, power in AC circuit. Generally we know that in a DC, what is the power? There is no phase angle. The power is not depending upon the time period. Voltage and current also not depending upon the period. Then what is power equation in DC? P is equal to voltage into current. It is a direct current. Power is equal to voltage into current. What put in AC circuit? What happening in AC circuit, guys? Voltage and current both are is depending upon the time period. Simultaneously, both voltage and current will be changed with respect to the time period in a AC circuit. Then that's why we are considering here average power. Total power will be 0. That's why here we are considering as a average power. The rate at which electrical energy is consumed in a electric circuit, it is called as a power. In a AC circuit, what is the power equation? Here we are considering as a average power. In DC, it is P is equal to voltage into current in DC. What about in AC? We are considering power as a average power. Why? Because in AC circuit, voltage and current both are simultaneously changing with respect to the time period. That's why here we are considering as a average power. Then we will find out the average power. P is equal to V into I. We know that V is equal to I is equal to. What is the equation, guys? V is equal to V naught sine omega t. I is equal to I naught sine omega t plus phi. P is equal, substitute V and I here. V naught sin omega t into I naught sin omega t plus 5. T is equal to V naught into I naught sin omega t into sin omega t plus 5. We know that one formula, guys. What is the formula I am telling? 2 sin A sin B. 2 sin A sin B is equal to cos of A minus B minus cos A plus B. We know that in mathematics. 2 sin A sin B is equal to cos A minus B minus cos A plus B. This formula we will use here. P is equal to V naught I naught. Here A is omega t, B is omega t plus 5. Then cos, what is A? Omega t minus omega t. Here plus will be minus. In minus 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 cos A plus B. Omega t plus omega t plus 5. Simplify this equation. Simplify this equation. P is equal to V naught I naught. Omega t will be cancelled. Cos minus 5. Here it will be minus cos 2 omega t plus 5. But here, what is the average power? It is depending upon the time period? No, it is not depending upon the time period. But here, this cos is depending upon the time period P. That's why this total value will be 0. We are considering here, this total value will be 0. Why we are considering it is a 0? So, average power it is, not a normal power. It is a average power. Average power is not depending upon the period. But here we are getting the time period. That's why this total value will be 0. Average power is 0. That's why here we are considering it is a 0. Then P average is equal to, what is the final formula now? P average is equal to V naught. Sorry. We forget to take here by 2, guys. Sorry. By 2 into 2 here. Here 2 is not there. That's why here we are taking by 2 into 2. 2 will be cancelled. We will get same equation. Then 2 sin omega t plus 5. Apply for this formula. 2 sin A sin B is equal to cos A minus B minus cos A plus B. Then here also we are getting by 2. Sorry. So P is equal to V naught I naught by 2 into cos minus 5 minus cos 2 omega t plus 5. Here it is depending upon the time period. No, average power is not depending upon the time period. That's why this value will be 0. Then final equation is P average power V naught by I naught by 2 P average is equal to V naught I naught by 2 cos minus phi. But here we know that cos of minus theta is equal to cos theta. Therefore, P average is equal to V naught I naught by 2 cos. Then we know that V naught by root 2 is equal to VRMS. I naught by root 2 is equal to IRMS. P average is equal to, I am writing 2 as a root 2 into root 2. V naught by root 2 into I naught by root 2 cos phi. Then what is the power equation? Average power. P average is equal to VRMS. We know that V naught by root 2 is equal to VRMS. VRMS into IRMS cos phi. This is the average power equation. Average power equation. This is the power equation in AC circuit. What is the power equation? VRMS into IRMS cos phi. Here we are considering two cases, guys. P is equal to, we are getting VRMS into IRMS cos phi. Here we are considering two cases. Case 1. I am considering phi is equal to 0. When phi is equal to 0, it is purely resistive circuit. Then it will be a pure resistance circuit. When the cos phi is equal to what? 1. Phi is equal to 0. Angle between the voltage and current will be 0. Then cos phi is equal to cos 0. Cos 0 is equal to 1. So cos phi how much? Cos 0. Cos 0 is equal to 1. When it will be? It is a pure resistance. Then what is the average power? P is equal to VRMS into IRMS. P is equal to VRMS into IRMS when phi is equal to 0. Next, I am considering it is an inductive and capacitive circuit. What about average power? Case 2. Case 2, phi is equal to pi by 2. It is a inductive. It is a inductive and capacitive circuit. Phi is equal to pi by 2. Then cos phi is equal to cos pi by 2. Cos pi by 2 how much? Cos 90 degrees. How much? 0. Cos value will be 0. Power also 0. Average power is equal to 0 in a pure inductive and capacitive circuit. It is a pure resistive circuit. We will get maximum power. It is a pure resistive and it is a pure capacitive and inductor circuit. We are getting here power is 0. While current is passing through the circuit also, through the inductor and capacitor, we are getting here power will be 0. Okay, guys. Next one is wattless circuit. This is we called as a pure inductive and capacitor circuit. In a purely inductive or capacitive AC circuit, the phase difference between V and I is I by 2. Angle will be pi by 2. What is the power factor? Cos phi is equal to cos pi by 2. Already we discussed it will be a 0 when the average power also 0. Average power also 0. No power is dissipated even through current is flowing through the circuit. Current is flowing through the circuit also. We are getting here average power will be 0. It is we called as a wattless current. It is we called as a wattless current. Next one, power factor. Next one is power factor. The average power of an AC circuit is given by, we know that already, P average is equal to V RMS into I RMS cos phi. Average power is equal to V RMS into I RMS cos phi. Here we are considering this VRMS into IRMS, we considering as a apparent power. This average power we consider as a true power. Then what is the formula? True power is equal to apparent power into cos phi. Apparent power into cos phi. Then cos phi is equal to cos phi is equal to cos phi is equal to true power by apparent power. Cos phi is equal to true power by apparent power. Then here we know that Z or it is Xc minus XL. Then we are considering here angle is phi. Angle is phi. Then cos phi is equal to, what is the diagram? It is a rectangular, it is Z, it is or it is Xc minus XL. Then what is the phi equation cos phi? Cos phi is equal to, what is the formula for cos phi? What is the formula for cos phi? Adjacent side by hypotenuse. R by Z. R by Z. This is the formula for the cos phi. When here at a pure resistor, here we are considering resistance only, then what is the average power? V average is equal to V RMS into I RMS at a resistance circuit. At a resistance circuit. Next one is resonance. Next one is resonance condition. What is the resonance condition? A series LCR circuit is said to be in resonance condition when current through it has maximum value. Maximum value. That is we called as a resonance. That is we called as a resonance. In LCR circuit, when we are getting the maximum value, maximum current, guys, when we will get maximum current? When it will be a pure resistor, then only we will get the maximum current. So that's why here what will happen? Xc minus XL value will be 0, then we will get the pure resistance. When it will be 0, XL is equal to Xc, then it will be the 0. So maximum value. We know that what is the current equation? I naught is equal to V naught by root of R square plus Xc minus XL whole square. At a resonance condition, we are getting the maximum current. When it will be maximum? Xc is equal to XL. This is we called as a resonance condition. At Xc is equal to XL, we are getting the maximum current. How? I will explain. Here I naught is equal to V naught by, here Xc minus XL both are equal. This total value will be 0. This total value will be 0. This total value will be 0. Then finally we are getting V naught by R square. I naught is equal to V naught by R square. So V naught is equal to, I naught is equal to V naught by root of R square. Then I naught is equal to V naught by R. This is the resonance condition. Here resistance is inversely proportional to the current. Resistance will be minimum, then the current will be maximum. Here voltage and current both are in phase, then we will get more power at a resonance condition. At a resonance condition, inductive reactance is equal to the capacitive reactance. At this point, we will get the maximum current. Next one, resonant frequency, where we are getting the maximum amplitude. That frequency we called as a resonant frequency. Where we are getting the maximum amplitude, that frequency we called as a resonant frequency. What is the condition for resonance condition? Xc is equal to XL. Xc is equal to XL. What is the formula of Xc? 1 by omega C. For XL, it is a omega L. Then omega square is equal to 1 by LC. Omega square is equal to 1 by LC. Omega is equal to 1 by root of LC. 1 by root of LC. We know that omega is equal to 2 pi f frequency. 2 pi f. 2 pi into frequency. It is equal to 1 by root LC. Therefore, frequency is equal to, we will write frequency like this, or f. Frequency f is equal to 1 by 2 pi root LC. This is the resonance frequency equation. This is the resonance frequency equation. What is the resonance frequency equation? F is equal to 1 by 2 pi root of LC. This is the resonance frequency. Then what is the diagram for the resonance frequency? I am considering it is a frequency. It is a amplitude. This is the resonance frequency diagram. Where we are getting the maximum amplitude, guys? When XL is equal to XC or XC is equal to XL, then at that point we are getting the maximum amplitude. So this is the resonance frequency diagram where we are getting maximum amplitude here. At this point, XL is equal to XC. At this point where we are getting the maximum value, at this point XL is equal to XC. XL is equal to XC. At this point we are getting the maximum amplitude. Here it depending upon the resistance also. What is the equation? Frequency equation 1 by 2 pi root LC, 1 by 2 pi root LC. So here what is happening? Depending upon the resistance also, depending upon the resistance also it will be changed. Resistance will be low, then the current will be maximum. I naught is equal to V naught by R. I naught is equal to V naught by R. Resistance will be decreased, current will be increased. Resistance will be increased, current will be decrease. Current will be decrease. So here I am considering this resistance will be 100 ohms. Here we are getting current. Then I am considering R is equal to 200 ohms. Then like this we will getting. R is equal to 200 ohms. Why here we are getting, comparing with the 100 ohms we are getting less current. Why? Resistance is inversely proportional to the current. Here resistance is increasing, that's why current will be decreasing. So resistance will be increase, it will be so flat. So resistance will be maximum, then current will be 0. This is the resonance frequency condition. Resonance frequency, XL is equal to XC. What is the resonance frequency? This all those things here I explain. Sharpness of the resonance. Already I draw the diagram. This point we consider as a sharpness of the resonance. The graph shows variation of current amplitude in series LCR with the angular frequency. The current amplitude has a peak at a resonant frequency. At this point we are getting the maximum value. What is the condition here? Capacitive reactance is equal to the inductive reactance. The resonant frequency is independent of R, but the sharpness of peak depend on R. So this sharpness is depending upon the R. Why? I naught is equal to V naught by R. Current is depending upon the resistance. This sharpness is depending upon the resistance, but frequency is not depending upon the resistance. Resonance is sharp for small r and flat for large r. Already I discussed this value will be resistance is less, then this value will be resistance is maximum. Here R is 100 ohms, here R is 200 ohms. Here we are getting less current. The resistance will be increase, the graph will be like this, flat. Next one, transformer. This is also very important topic. This device used to change the alternating voltage from one to another without any change in electrical power. So, what is happening? Alternating voltage will be changing with any change in electrical power, without changing in any electrical power. So by using the transformer, alternating voltage will be changed from one to another with change in electrical power. What is the working principle of a transformer? Working principle of a transformer is mutual induction. Already we know that what is self-induction, what is mutual induction. Again I will explain. What is the self-induction? In one coil we are giving supply. In that coil only we are getting the EMF, that is we called as a self-induction. What is the mutual induction? We are giving for one coil we are giving supply. In that coil we are getting the current. But another coil is near to that coil. In secondary coil also we are getting the EMF, that we called as a mutual induction. Here we are taking two coils. For one coil I am giving the supply, but in another coil we are getting the EMF. Why? It is near to the first coil. That's why this magnetic field is passing through the secondary coil. The field is cuts the coil, then EMF will be induced. That is we called as a mutual induction. There is no connection, but here we are getting the EMF, that is we called as a mutual induction. Here we are having two types of transformers. One is step up transformer. It is depending upon the voltage. Transformer will be two types: step up transformer and step down transformer. Step up transformer and step down transformer. A transformer convert low voltage to higher voltage, that is we called as a step up. What is happening here? Low voltage to high. That's why it is called as a step transformer. Voltage will be high to low. High to high voltage to low voltage. It is called as a step down. Voltage is reducing. That's why it is called as a step down transformer. Voltage will be low to high. It is called as a step up transformer. Voltage is converting from high voltage to low voltage. It is called as a step down transformer. Then what is the construction for the step up transformer and step down transformer? First of all, for a transformer, two coils is there. Primary coil and secondary coil. How many types of coil windings is there here, guys? Two windings. Primary winding, secondary winding. Which one we call as a primary? Which one we call as a secondary? Which winding is connected with the supply, that we called as a primary winding? Which winding is connected with the load, that winding we called as a secondary winding? Which winding is connected with the supply, that is we called as a primary winding? Which winding is connected with the load, that we called as a secondary winding? So first of all, what is the difference between the step up and step down transformer? Already we discussed EMF is depending upon the E is equal to minus N d5 by dt. So EMF is depending upon the number of turns. Number of turns is more, but the flux is also more. So then EMF also more. Number turns will be increasing, EMF also increasing. So according to this relation, EMF is directly proportional to the number of turns. So step transformer, what is happening here? What is happening? Low voltage to high voltage. So in a secondary side we are getting the high voltage. It means in secondary side number of turns will be more. In a step down transformer, in a secondary side number of turns is less comparing with the primary winding. This is the difference between the step up transformer and step down transformer construction. First of all, I am considering it is a step up transformer. It is a step up transformer. What is the step up transformer condition? I am considering it is a primary winding. I am giving here supply. So here number of turns is NP. It is a EP. Primary voltage. Here we are getting primary current. In secondary side, why I am taking here number of turns is more? It is a step up transformer. Number of turns is more, then the low voltage to high voltage it will be convert. That this is the difference between the primary winding and secondary winding. It is a step up transformer. That's why in the secondary side number of turns will be more. It will be connected to the load. Here we are getting secondary voltage, secondary current, secondary side number of turns. Then I am taking another coil. It is a iron core, guys. It is a iron core. So here it is a step down transformer. It is a step down transformer. It's a step down transformer. That's why it in the primary side number of turns is more. But in the secondary side number of turns will be less compared to primary. It is connected with the load. Here we are getting secondary voltage, secondary current, secondary side number of turns. This is the difference between the step up transformer and step down transformer regarding the construction. What is the differences between the step up and step down? First difference. It is a step up transformer. Number of turns at a secondary side is greater than the number of turns at the primary side. Here it is a step down transformer. Number of turns of primary is greater than the number of turns at secondary. So where we are having number of turns is more at the secondary side in the step up. That's why voltage also more. I am considering ES is a VS. VS is greater than the VP. Here where we are getting number of turns is more at the primary side. That's why primary side voltage is greater than the secondary side voltage. Third one, but current is here reverse. Here IP is greater than the secondary current. Primary current is greater than the secondary current. Here secondary current is greater than the primary current. Next difference, thickness. Thickness of second coil, thickness of second coil or secondary winding. Thickness of secondary coil is less than the thickness of first coil. Thickness is more, the resistance is more, current will be less. That's why here thickness of secondary winding is less than the thickness of first coil. Here opposite. thickness of first coil is less than the secondary one. This is the difference between the step up and step down transformer. Here I am considering EP as a VP, ES as a VS. ES as a VS. We know that E is equal to, I am considering here only magnitude, then it will be a E is equal to N d phi by dt. Then what is the equation? VP is equal to NP into d phi by dt. VS is equal to NS into d phi by dt. VS is equal to NS d phi by dt. Then Vs by Vp is equal to d phi by dt cancelled. Then it will be a Ns by Np. Ns by Np. This is the first equation. And one more thing, it is an ideal transformer. It is a ideal transformer. Input power is equal to the output power. There is no minimum resistance and there is no leakage currents. That's why input power is equal to, I am considering it is an ideal transformer. Input power is equal to output power. Input power is equal to output power. It is an ideal transformer. Vp into Ip is equal to Vs into Is. Vs into Is. Vs by Vp is equal to Ip by Is. This is the second equation. Compare 1 and 2 equation. What is the first equation? What is the first equation? Vs by Vp is equal to Ns by Np. This is the first equation. This is the second equation. Compare 1 and 2 equation. What is the transformer equation? Transformer equation. Transformer equation is equal to Vs by Vp is equal to Ns by Np is equal to Ip by Is. This is the transformer equation. Ns by Np. Here Ns by Np we called as a ratio. Ns by Np we called as a ratio. It is a ideal transformer. It is a ideal transformer. It is a ideal transformer. What is the efficiency equation? What is the efficiency equation? Generally, efficiency is equal to output power by input power. So, what is the, it is an ideal transformer. What is the output power? Vs into Is by Vp into Ip. So, it is in a percentage. Efficiency is equal to Vs into Is by Vp into Ip. Output power by input power. When this is formula is applicable, it is a ideal transformer. Next one, what are the losses occurred in a transformer. It is not a ideal transformer. What will happen? So these are the losses for the transformer. What are the losses? First one is flux leakage. Flux leakage means, see here in a primary winding we are getting some flux. That total flux is not passing through the secondary coil. Some flux is here wastage. That wastage we called as a fluxed wastage. Flux leakage. The magnetic flux produced by the primary may not fully pass through the secondary. Here total flux is not passing through the primary to secondary. Some of the flux is here wastaging or leaking into the air. This loss can be minimized by winding the primary and secondary coils over one another. We will connect, then we will reduce this leakage. Otherwise we will reduce this loss. Next one is Joule's law or copper law. We called it is a Joule's loss or copper loss. Energy loss in the form of heat in copper coil is I square or T. So energy loss in the form of heat in the copper coil is equal to the I square or T. This can be minimized by using thick copper wire. When we will use the copper wire is thick, then the Joule's law or copper loss will be reduced. Next one is eddy current loss. Third one is eddy current loss. The alternating magnetic flux produced eddy current in the iron core, which leads to waste of energy in the form of heat. This is we called as a eddy current loss. This can be minimized by using the laminated core. By using the laminated core, the iron core will be laminated, then the eddy current losses will be reduced. Next one is hysteresis loss. Next one is hysteresis loss. As the AC current passes through the winding, the iron core undergoes repeatedly magnetization and demagnetization. So in the inductor coil, it is an inductor coil. That's why here magnetization and demagnetization continuously happening. That's why here hysteresis losses will be occurring. As a result, some energy is wasted in the form of heat that we called as a hysteresis loss. Can be reduced by using the core material having narrow hysteresis loop. Narrow hysteresis loop we will use, then we will reduce the hysteresis loss. Next one, final one, AC generator. Final topic today, AC generator. First of all, what is a generator? What is a generator? Mechanical energy is converted into the electrical energy we call as a generator. By using the generator, mechanical energy is converted into the electrical energy. Here, what is the diagram for AC generator? I am considering North Pole, South Pole. In between two coils, I am considering the coil. So, according to the Faraday's law, change in flux produces the EMF. So, in between North Pole and South Pole, in between North Pole and South Pole, magnetic field lines will be passed. So, from the North Pole to South Pole, magnetic field lines is passing. When the magnetic field lines will be cut the coil, then only EMF will be produced. Here, the change in flux only produce the EMF. We know that according to the Faraday's law. That's why this coil will be rotate. The coil will be rotate. And one more thing, coil will be rotate and the magnetic field cuts the coil. Then only we will get the EMF. So here, the in between magnetic field and coil, phi is equal to, angle is equal to 90 degrees or 270 degrees. Then only we will get the maximum EMF. Then only we will get the maximum EMF. Why? E is equal to N d phi by dt. Phi is equal to, we know that BA cos theta, or phi is equal to BA cos theta is here omega t. Omega is the angular frequency. Then E is equal to N d by dt BA cos omega t. Then E is equal to N BA d by dt cos omega t. We know that cos omega t is equal to sin omega. Here minus is there. E is equal to minus NBA minus sin omega t. Then E is equal to NBA sin omega t. So here omega t is equal to 90 degrees, or omega t will be 270 degrees. E is equal to E naught. E naught is the maximum value. E naught is equal to the maximum value. Then E is equal to E naught sin omega t. Then I is equal to, here I am considering resistance is R. I is equal to E naught by or sin omega t. I is equal to I naught sin omega t. This is the current equation and this is the voltage equation. Check here guys, both voltage and current is simultaneously changing with respect to the time period. So in the AC generator, what is happening? Finally, what we conclude? Generator will be converted mechanical energy to electrical energy. See here how we will conclude that one. So here coil is rotating. Coil is rotating means which energy it is? Mechanical energy. Here we are getting alternating current. It is a electrical energy. Coil is rotating, then we are getting the electrical energy. It means what? Mechanical energy is converted into the electrical energy. This is the portion of the alternating current guys. Hope you understand all those topics. So tomorrow our Kamala ma'am will come for the live session. Thank you.